Show that cosine of 2u equals cosine squared of u minus sine squared of u equals 1 minus 2 sine squared of u, and also equals 2 cosine squared of u minus 1. There are three equations here. Because of the three equal sign, we will show one by one. Basically, there are three trig identities here. We will show one at a time. First, we start with the left-hand side, which is cosine of 2u. Recognize that 2u is simply u plus u, because we know the addition formula for cosine. Cosine of u plus u is cosine of u times cosine of u, where the first angle is u and the second angle is also u, minus sine of u times sine of u. But this is cosine of u squared minus sine of u squared. Or, in a nicer notation, this is cosine square u minus sine square u. So we establish the first equation. Next, we want to show that this result is also 1 minus 2 sine squared of u. And so, we will pick up where we left off, and we start with cosine of 2u equals cosine squared of u minus sine squared of u, which is what we just showed. This time, there is no cosine in this expression, so we will need to rewrite cosine in terms of sine. But using the trig identities, the Pythagorean identities, we have cosine squared of u minus sine squared of u, where cosine squared of u is 1 minus sine squared of u, because the Pythagorean theorem states that cosine squared of theta plus sine squared of theta equals 1. And so we isolate cosine squared of theta, or in this case, cosine squared of u. We obtain 1 minus 2 sine squared of u, which establishes the second identity. Now, we start with the same result. Cosine of 2u equals cosine squared of u minus sine squared of u. But for the last expression, there is no sine, so we will replace sine with an expression in terms of cosine. Isolate sine squared, we have sine squared equals 1 minus cosine squared. We rewrite this cosine square u minus, but this sine square u is now 1 minus cosine square u. Combined like terms, we have 2 cosine square u minus 1, which establishes the last identity. And we are done.